Welcome to this episode of Mr. Layman's Knowledge Explosion. In Unit 6, Lesson 1, we're going to talk about parallelograms. Now, a parallelogram, by definition, is a quadrilateral with two sets of parallel sides. So a quadrilateral, we know, means has four sides. So let's construct that four-sided figure with two sets of parallel lines. So as you can see, I've got one line drawn, and we know that through any point not on that line, there should be exactly one line parallel to my first line. So I'm going to construct that parallel line. Now a quadrilateral has to have four sides, so I'm going to draw another line. Any line will do. And then I'm going to construct a line that is parallel to that. And when I do that, you can see that I have 4 points here, 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 and here that have created a quadrilateral. But more specifically, since the lines I used to make that quadrilateral were parallel, this figure inside here is a parallelogram. And when I move the points around, this shape inside remains a parallelogram. So I can move this way or that way and move these points, and it changes the shape a little bit. And you can see that I can make lots of varieties of parallelograms using those 4 points. So this is a nice tool for exploring what a parallelogram is. Now there are 4 things that this parallelogram has as its properties. For example, if I measure the top length here to 8.48 centimeters, that length has to be exactly congruent to the bottom length CD. So no matter where I move these, so watch those two numbers, no matter where I move these, those two have to stay the same because I was using parallel sides. So no matter what happens in a parallelogram, those opposite sides are going to be congruent. And it's not just the top and bottom. If I were to measure A to C, and I find that that distance is 8.05, and then I measure from B to D, and I measure that distance, I'm going to find that that is exactly the same. So no matter what happens, these opposite sides are going to be the same. Whether I shrink this and make a new parallelogram there, almost looks like a rectangle, or I make it bigger, those sides opposite each other are always going to stay congruent. So that's property number 1. The opposite sides of a parallelogram are always congruent. Now if you look at the angles, A compared to D and C compared to B, it appears that those angles are also the same. So I'm going to measure those. Angle ABD, we'll measure that angle, is 75.03 degrees. And I'm going to measure angle ACD, which would be the opposite angle of that, and it's going to measure exactly the same, 75.03. Now that could just be this particular parallelogram, but if you watch as I move the points around, those angles stayed 75.03, but I could change the angles a little bit. But what's important to note is they stay exactly the same, even to the 100th degree. They are congruent. So the second property we need to understand is the opposite angles of a parallelogram are congruent. And again, it's not just one set of sides. Angle BAC should be the exact same measurement as angle BDC, which would be opposite of angle BAC. And when I measure that, you can see, in fact, they are the same. Now, what's interesting to note is when you look at angles right next to each other. 80.48 and 99.52 add up to exactly 180 degrees. So that means any two angles right next to each other, angle A and angle B, are going to be supplementary. Likewise, angle A and angle C are going to be supplementary, and angle B and angle D are supplementary. So we have two ideas that come out of looking at the angles. The angles opposite of each other are congruent, but the consecutive angles, or the angles right next to each other, are supplementary. So there's 3 of the properties that I want you to know about parallelograms. Opposite sides are congruent, opposite angles are congruent, and your consecutive angles add up to 180 degrees, or simply said, are supplementary. Now the next one, as we play with our parallelogram here, we can keep looking and moving these points around, and you'll notice that the opposite sides always stay the same with the angles. But if I draw a segment from A to D, that's called a diagonal. and if I draw from C to B, that would be called another diagonal. A diagonal means you draw from one vertex to a non-adjacent vertex, or a vertex that is not right next to it. In every parallelogram, there are exactly two of those diagonals. And as I move this around, I can see that they will also move. And I'm still noticing that my angles stay the same no matter where I move this. My sides stay congruent no matter where I move this. But what I notice is these two sides look to be exactly the same. So if I put a point right here at the intersection of AD and BC, I'm going to measure the distance from A to that point, and I'm going to compare it to the distance from that point E to point D, and sure enough, they're the same. Now, is that just this parallelogram? Again, watch those two numbers as I move this. As I move this, those two stay exactly the same no matter where I move my parallelogram. To make it big, make it small, make it thin, make it wide, those two numbers, AE to ED, stay exactly the same, which means the diagonals of a parallelogram meet at the midpoint of each other. Because in fact, if I measured C to E, and then I measured from E to B, so measuring from E to B, I'm going to see that those two are also exactly the same. So we can come up with a nice way to say this. Instead of saying that the diagonals meet at each other's midpoint, we're going to say that the diagonals of a parallelogram bisect each other. Or in other words, they cut each other in half. And those are the four properties of parallelogram that I want you to be familiar with. So I apologize if my picture gets confusing, but I want you to see here that it doesn't matter where I move the parallelogram, these things remain true for every single parallelogram that I draw, whether it's big, whether it's small. Number one, the opposite sides will always be congruent. Number two, the opposite angles will always be congruent. Number three, the consecutive angles will always be supplementary. And number four, the diagonals will always bisect each other.